Okay, it's after 5. I've started recording. Start looking at a few things for the class. As you can see, the background's a bit different than than before. um, I'm in my son's house in Colorado Springs, um, and uh, the rooms looks a lot different. So uh, guess I can uh, go look at the slides uh, and okay, share um, uh, PowerPoint. And I probably should go to the beginning. Um, and minimize that. And um, okay, so I am recording. Um, it's a slideshow from the beginning. Right. Well, this is where we are today. Guess we've had a few more people arrive.
That's me, Brad.
You and Brad. Okay. Brad. Yeah. Okay. Go back to that. All right. You usually do. We'll look at simple regression, another procedure in the class, and I guess I got the attendance. And what's worked with the attendance last time is when okay, I can stop the share and maybe then I can just share the screen and use the drawing tool to mark the attendance. Okay. See on this first page who's, oh, share, share the screen. Okay. And I can open that, the participants view. Let's see. Joe Blackcrow here. And don't see Kimmy Mila. I haven't seen her for a while. I probably should take care of that. Felicia's here. Ryan, he's here sometimes. Let's see, not yet. Jermaine is here. Terry Haskell here yet? No. Eleanor Hornbeck, haven't seen her. Janice, make it yet?
I'm here.
Okay, okay. Got a chat message. Okay, all right. In and out of service, Samantha. Okay. And we were back there, and Terry, haven't seen her yet. Chat. Tiff King, I'm here. Okay. Oh, Terry's here. Good to see you, Terry. Just about to be calling your name. Saw Janice. Yeah, Janice Joel's. Oh, Joel Janice. Okay. Brad, saw Brad. Brad's there. And who else we have? It was, I look at my chat messages. It was Tiff. Okay. Tiff is here. And, oh, Tiff is there. Tamara's here. Let's see. More chats. I'm here tomorrow. Okay. Yeah. Is Megan here? She might show up a little later. Joni. Don't see Joni yet. Did I see Christina there?
I'm here.
Oh, okay. Yeah, just trying to look all this stuff over. Tony, yeah, definitely here. Victoria, which Victoria?
Pina?
Pina, okay.
All right. Yeah.
Okay. And I think I saw Brittany. Did I see Brittany? Or no? Yeah, there's Brittany. See, saw Justice and I saw Shaw, I believe. See, Shaw and Sherry. Haven't seen her. Okay, and and all right. So I'm sharing the whole screen with the attendance, and it's where I'm at. And And we can go to there and maybe then we can share, right? Home and slideshow, and somebody just arrived. See if I can notice a new name. Tip tomorrow. Didn't notice a new name there. Unless it's a second Victoria. See two Victorias. Okay. Notes on status. Yeah. Where are we? We're getting pretty close to. Should be seeing the syllabus for the class now. We're in the simple regression week, the 9th. Then we'll have one more week of material scheduled, the chi-square test, and then review and catching up on homework for the final. So, and the 23rd is just before Thanksgiving, and the 30th is just after. Yeah, it's going to be a different kind of Thanksgiving this year because, well, people aren't recommending travel as much, or I guess some of you on the res are, well, some of you on the Pine Ridge Reservation are under more lockdown. Yeah, I don't know what'll happen otherwise. Being getting to my son's house has been kind of difficult. So one more week of regular topics, and then we'll go onward and start cleaning up. I'm thinking I might try to get the exam ready on the 23rd and go over some hints and so forth. I believe I've returned some of your exams on your first exams on Genzibar. I may not have collected everything right, but I have uploaded them, the marked up sheets. We'll see how well I can do is in getting back to things. Coming here to my son's house has changed a few things, and hopefully we'll be able to open up some more stuff. Let's see. Guess I could close this and get back to slideshow from current slide. Yeah, notes on status. So oh no, more. Okay. Joni's here. Okay. Thank you. And can I go backward? Okay. And get my pen back. All right. So if anybody else arrives, or I guess I can flip through the names. If your name isn't checked and you're here, why? There were two Victorias logged in, but I don't know if it was the same person. If it was Victoria Pena logging in two different accounts, so either send me a chat message if you're not marked, or speak up. Usually Megan's around. I guess so. I guess I could have some notes on status. Returned some exam 1 results on Genzibar. And then another note. Oh, video link for recorded classes are now on YouTube. Okay. Yeah. So I guess it was I guess now it's about a week and a half ago. All right. If it's somebody first coming in and I haven't marked you, either send me a chat message or speak up. Haven't marked Ryan. He's often here. Megan's often here. Haven't marked Victoria Phelps, and she's often here. Okay. I'm here. Okay. All right. Pop back. Victoria Phelps. Okay. Got that done. So maybe Ryan Charging Cloud will be here. Megan Martin, maybe. Haven't seen Sherry in a while. Video links for recorded classes are now on YouTube. I think they work. I haven't I haven't like bounced to different machines to verify I could get on with the link. So has anybody looked at the YouTube videos?
I have not.
Okay. All right. So video links for the recorded classes are now on YouTube. Yeah, yeah, that wasn't too hard to get done. Um, uh, anyway, yeah, traveling here to Colorado Springs and getting some other things arranged and kept me busy. As well as I guess last time I talked, I hadn't uploaded the videos to YouTube, which was some technical work. And talk about this new subject then, simple regression. What you know, Pearson's R, and we did talk about partial correlation and Spearman's rank correlation, sometimes called Spearman's row, and point biserial correlation we mentioned. Correlations do not differentiate between independent predictor and dependent criterion values. So correlation of X versus Y and Y versus X will be the same. Just a feature of the correlation coefficient. So we had looked that over last week, and some of you may have gotten to the homework. In what's new is in simple correlation, there's one predictor and one criterion variable or response. Okay, so we know we're trying to make things. We exercise this number of hours, we gain so much calories. We what would we do? We attend class so many hours. We we attend class so many times. We get certain grades. Um, yeah, yeah. This is it's different. It's yeah. We switched to daylight savings time at I guess the beginning of last week, and it's and now looking out a dark window. It's odd how things are done at my son's house here. He's uh, someone who I didn't mark here just arrived. Okay, so either give me a chat message or speak up. Um, so the main purpose of the regression is to use X's to predict Y. So we really want to predict things. Sales based on the day of the week and the outside temperature, or based on sales. If you're in a restaurant in a downtown area, the hotel occupancy might be a good predictor of your sales. Um, uh, uh, what other things would be a predictor? How many hours of church services might be a good predictor of what proportion of your income you donate to church. Or I guess we could use public radio or some other broadcast thing too. The best fit line is depicted by a straight line that goes through the averages, X bar and Y bar. And then minimizes the vertical distances between the y minimizes the vertical distances between the actual values and the predicted values, denoted. Actually, not quite. It's minimizes the sum of the. There are different ways to interpret minimizes vertical distances. There's one particular technical way of describing that, though, that we usually use. And when we put this symbol above a character, we say hat. So we say Y hat for this symbol. And for these symbols, this is X bar and this is Y bar. Yeah, I hope you don't hear it, but I got a little household noise in the background. I have the microphone right by my face, so and the door closed, so I doubt you're picking up much of that. Simple regression is the most commonly used linear predictive method when making quantitative predictions of the criterion Y based on the values of X. Fair enough to say that, yeah. Many straight lines could fit the data points, but the best fitting line is the linear regression line that produces, and this is the minimal sum of squared distances. So Y hat, it might be good just to write this. Minimize, and some of you have learned to like symbols already. The sum of Y, which is the observation, minus Y hat, and we might subscript these with i's if we want, and square them. So, and I equals 1 through n. So we pick our Y hats to minimize the sum of squares. Is that the best way to do it? The math works out real clean is probably the best way of saying this. There are some problems with it. So that's what this expression here is, the minimal sum of squared distances between Y, and this is the observation, and this is the fit value. So maybe I should write that too. And P. This is the observation. And this is the fitted value. Fitted value. Or you could say predicted value. Um, the best fitting line is mathematically described by the smallest sum of squares errors. Yes, same expression I did there across all data points. The regression line is an equation for the regression line. You can, I don't think the mic will pick you up. Um, the regression equation in y hat is equal to a plus bx, and the slope uh, uh, okay, this is the slope. This is called the y-intercept. You may remember that from your algebra class. You may not. So this is slope. This is intercept. And calculations are these terms SB, SX, and SP. I believe we calculated last week. And the y-intercept is y bar minus x bar minus the slope term. So we can just calculate those values and calculate the y-intercept. So ordinary least squares predicts the best fitting line that goes through x bar y bar and minimizes the vertical distances between the predicted. So yeah, and we call that simply ordinary least squares, the procedure that does this best fitting. Let's see. Example 12.1, calories burnt this way. Let's just take a look at how to do this, and I can stop the share and put up Excel. Just show you how easy it is with Excel. So let me stop the share, and then I can share my Excel file. And I've got a couple of Excel files. This one, share that Excel file, that's the data. And did I, sharing, okay. We can view, okay, view, zoom, maybe double it up for the magnification on the Excel file. We're recording, go back to home, and what I didn't put in, these are hours, and this is calories. And this is data. We had hours exercise, calories burned, depending on what you could get, a calorie monitor device on your wrist. the what is this? Apple Watch will monitor that. You can get cheaper. You can get a Fitbit. Cheaper than that, you can get a knockoff of a Fitbit that will monitor your calories. So, and how will we do this regression? In Excel data. And if you load in the data analysis pack, which is a add-in in Excel, a standard add-in, you then, when you pick it up, what's this? Oh, I'm not in the right. I'm editing something. Just highlight this, I guess. Data analysis. And in this list, you then can pick up the word regression shows up, and you can go okay. And now you have to get a Y range, and you can select this for a Y range, and then you can go down next one and select this for the X range, the input, and then you put the labels. You generally don't want to click the constant is 0. You might want to add a confidence level of prediction. You can assign a new sheet, new worksheet ply, and just a new worksheet ply. So you could use HR cal result. That's probably the way to keep it neatest. You can put it on the same page. It's nice to look at line fit plots, and there are a few other things that are available here. And once you do that, you just hit OK. And here is your predicted picture. We can stretch it out a little bit to get a better look. So the blue data are the observed things that were typed in. The dots are the fitted lines. And let's see, we have the intercept, the coefficients here. This is the intercept, 300, 300, and then the hours are the coefficient for hours. This is, let's see, can I draw on this? Yes, I can. So I can draw. So right here, this is A. And then this is B. Okay. And maybe these should have hats on them. I don't know the notation. Sometimes you'll put a hat on these values, the estimated values. I guess we could go back if we need to and stop the share on that. Let's yeah, let me look at the PowerPoint. Skip ahead a little to check to see the notation. No, we just calculated A and B. All right. So, well, we go back to Zoom and go back to sharing this. So we can get we can get the A and B values from the intercept and the factor, and these are called coefficients. So those are marked up that way. I hope you can see that. Maybe I should have zoomed in more. View, zoom, 200%. Will that make it easier to see? Yeah. Some of you may be looking on a phone. So that's where you find A and B in the results. And further on, we'll look at other results from here. And we then can see the predicted calories and the observations on this table. And I kind of stretched it up a bit larger than I should have. Oh, I'm in drawing mode. Go back to select. Okay. And make that picture a little smaller to fit this screen. All right. So that's a regression line in Excel. And we can also see the A and B automatically calculated. So you could probably go watch this in the video, and if you have the data analysis add-in, it's very simple. There are a couple of other things. There are we can go back to hours calories, and there is another term used called equal I, and you can type the word intercept and then select these no, it's sorry, this one for the intercept, we need to first do the X's and then a comma, and I'm wrong. You do the Y's and then the X's. So do the Y's and then comma, then the X's. So see if that gives us the intercept we had before. 397. So this is intercept. And we also have a command called slope, which works consistently. This is the Y, and this is the X, and 11. So this is slope, and can we go back to drawing? No. Yeah, we can go back to drawing. So this is this is B, and this is A, and we can see that that's consistent with what we had before. Same results. Now, this procedure doesn't draw you a graph right away, and doesn't provide other information in Excel. The slope and intercept terms, I guess I could make a note here. Also in Google Sheets. Okay. Now, I guess we've talked a little bit about advantages of Google Sheets versus Excel. Excel has more features. It's more common. However, you got to pay for it. Google Sheets has a few less features, but it's you just have to create a Google account. So it's kind of like YouTube. You can work with that. So maybe we can stop the share, and how to go about doing this kind of problem in Google Sheets. I looked it over, and I thought I'd just find a video. So let me look to see. Right. Yes. Right. We can go back there and share. Maybe we'll just share the screen. And I think I've clicked, oh, share computer sound, optimize screen for video clip, share, and we're now looking at this one Google Sheets for linear regression analysis. And I guess I can drag it back to the beginning and can start it.
Hi everybody, this is Mr. Poller. In this video, I'll be showing you how to do linear regression analysis.
Could you guys hear Mr. Poller?
Yes.
Okay, sounds good.
Using Google Sheets. So I've already set up a sheet that has the data that I want to analyze. We're looking at number of coins and the mass that they have. So I'm going to go ahead and highlight that data, and then I'm going to go to Insert, Chart. Now in this case, I don't want to make a bar graph, so I need to change this. So if I just go up here under Chart Type, the kind that I want to use is a scatter plot or scatter. Now, I have some other things that I want to display here. So I'm going to go to Customize in my chart editor. Now, if you lose the chart editor, if you double left click on the chart editor will come back. Now here, I've already pre-populated a title, but you can certainly go in and edit your chart title. If you want to do any editing of your axes titles, you can do this here too. We want to go ahead and add in the line of best fit for the linear regression analysis. You'll find that under series right here. I'm going to scroll down and I want to add a trend line. If I scroll down a little bit further, I will select my label, use equation is what we want. We also want to show this, the R-squared value. Okay, that's really telling us how well do our data points fit to our line of best fit. In this case, with a value of 0.999, it's a very good fit. I'm going to go ahead and move my equation. I don't really want it at the top of the graph there. I'll go ahead and put it over on the right so I can see that showing up over here now. Okay, sometimes in Google Sheets you can get some errors that produce some things that look kind of weird, and I want to show you what's going on, why those things might happen. So if I go ahead and click on my chart here and bring the chart editor back, if I go to horizontal axis, every once in a while this box gets checked. Okay, I'm going to go ahead and check it now. This equation is correct, but if I check on this box, you can see it's going to change the appearance of my graph. It didn't change my equation, so it's actually okay. The reason for this is really kind of interesting, all right? It's because I put this 0 here. Watch what happens to my equation if I take away this 0. So you can see if I do that, all of a sudden now, my intercept point is really wrong, right? It's still the same slope, but it's telling me the intercept is 2.76. It's really not correct. So I'm going to go ahead and put the 0 back in here. That's going to, again, fix my equation. Is fixing the intercept point. Going back to chart editor. Again, this shows up under horizontal axis, under customize, horizontal axis. Now, if I uncheck that, I can change the appearance of my graph. So it's really, up to me to make sure, that I'm making the graph the way that I want it to look. But if you find in Google Sheets that you're seeing an intercept that really doesn't match your data, please check under horizontal axis and look at this box right here. So I've shown you a couple of different ways that you can fix that issue. Thank you for watching. I hope you found this helpful.
Okay. Let's stop the share and back and escape and lose that. Okay. Well, for me, it's a little more difficult to get the results, but the slope and intercept commands are still available in Google Sheets. Yeah. So let's go back to the PowerPoint and let's see. Maybe we'll just share the screen. Share the screen and just pop up the PowerPoint show. So how do we do it? Example, you can go through this in Excel with those commands and get it done relatively quickly. The other thing is you can go through and calculate SP and SSX. And here's the steps for going about this. We have our data. We can compute averages like we did before. And these calculations of averages are things we've certainly seen. Summation of, so I can mark these. Control P. This calculation of the averages, and this line here is totals. It didn't make its way in. So this 37 is the summation of X. Okay. And the summation of Y, identify, summation of Y is here. And we now have those terms. That lets us go about and calculate. This then is SP. Run it across. This is SP. So when we total down that column, and then we also get this number here is here, and it's SSX. So these are the formulas we had before, and I don't know, maybe I should have used a highlighter and switch colors. And then we can then put these into the formulas for B and A, and come up with our equation. Yeah, you could set this up in a spreadsheet fairly easily, and then note these results and do these calculations, and come up with the same answers. Of course, you could just write here the slope or the intercept commands in Excel or Sheets, and get the same results. This also could be done with a hand calculation, but that's you know, kind of brutally difficult. Just would prefer not to do this kind of problem that way. So that's an example of how to get through it with a on your own Excel table to get the slope and intercept. How to use it. We've also showed the slope and intercept commands directly in Excel, the data analysis, and watch the video on how the slope and intercept commands are also in data sheets. and there there is a procedure for having a generating the regression equation directly with a graph in Google Sheets, which for me is a little hard to follow. So I let Mr. Pauler in the YouTube video explain it. Let's see, the deviation of y bar can be explained by the regression plus some unexplained parts. So this is the total differences of y from the average. This is y hat from the average, and this is y hat from the observation. And these, we can sum these terms, and they'll all work out with an equation. The unexplained deviation is what's missed by the regression. So another author of the slide, so this is explained by the regression, and the second part is unexplained by the regression. It's also referred to as error residual values and represents distance between y and y hat. To avoid positive errors completely canceling out the negative errors, we sum the squares. So that's an effect there, y minus y hat. It could be a positive number, it could be a negative number, but if we square it, we always get a positive number. These terms have been given names and things. So sum of squares error is y minus y hat. Sum of squares regression is y hat minus y. The sum of squares y is this. Sometimes this is called sum of squares total or SST. And it happens to work out that SST plus SSR plus SSE add up together. So that relationship is known. This is somewhat useful because we don't need to calculate all of these. For example, it's fairly easy to calculate SSY if you have a variance calculation, and then SSE, you have to check every point. And there are then relationships between the three values and related to R squared, the square of the correlation coefficient. So these relationships hold too in regression. And this kind of page here, kind of nice to know, and it makes somewhat nice multiple choice question for an exam. ANOVA summary table is to compare and contrast variances to regression and variances due to error. So with the simple linear regression, we have 1 degree of freedom in the predictor, and then we have SSR Sum of squared regression divided by 1 is the mean squared error due to regression. And that shows up in the ANOVA summary table. There are 2 degrees of, the 2 degrees of freedom. So MSE is, and there is a test of significance for the regression is calculated by an F-test. We calculate, it has 2 terms, an MSR and an MSE, and there's an F table for that. And it's pretty common to then summarize the results this way. And for the simple linear regression, this column will be the same, and our MSR calculations will, and MSE will be this, and finally our F. And we can test the F. If the F is large enough, the regression fit is significant. So, and if it's too small, it's not significant. So the two different degrees of freedom, and degrees of freedom, R is 1 and N minus 2. So the rejection zone here is calculated or looked up in the table, 1 N minus 2 for this, for the ANOMA summary table. So this is the big result for using an ANOVA table. Here's a stepwise look at doing this, and a statement of whether the regression is significant. Let's, what am I sharing? I'm going to stop the share, and we can share the PowerPoint. Share the, share the Excel file here. Now, the results page that we did has this ANOVA table in it. Okay, so this is MSR, this is MSE. These are the degrees of freedom. These are the appropriate SS values calculated. So all these numbers are calculated in the Excel output with an ANOVA table. So this is just part of the results in the summary output. And it gives you a significance level on the F. So this is a p-value or significance level. You don't even have to use the table if you have access to Excel with the data analysis tools in it. So go back and share the PowerPoint. Stop the share. New share. PowerPoint show. We can share that. All right. So saw what the ANOVA table looks like. We can state the pair of hypotheses what are we actually testing? So formally, we use beta to talk about the parameter. If we assume there is a straight line, it has a parameter, and beta is related to the b, so the slope. And we're testing to see if the slope is 0 or the slope is not 0. So it's only a one-sided test. One-sided test on beta. We identify the rejection zone is calculated with f is f greater than f1 n minus 2. So we can look up at our example that we had played with and compute n. N is 10, n minus 2 is 8. N minus 2 is 8. So we'd then be looking at 1 and 8 in our F table to see what we reject. Then we calculate this, we do the ANOVA summary table and get a machine to do that maybe. If the calculated F from step 3 is within the rejection zone, we reject H0. If the calculate is not, we fail to reject. And F is equal to MSR over MSE. So that's the procedure there. They go through the step-by-step calculations, what we did before, the calories burnt, and continued state the pair of objectives. This time, the rejection zone is F is equal to 5.32. Let's go back and look at the tables and see what that would actually be. Tables are in the textbook, and they're with the other tables. And degrees of freedom 1 and degrees of freedom 2. The top one is the one we'll always use the first column for problems in the chapter because it's degrees of freedom 1, and then read off the 8, and I read off it's on page 499. So column with the 1 in it, row with the 8 in it, and 5.32 is what we get. And we then could stop our share and we could share, we can share our tables and let's see, do I have an F table? T table, R table, chi-square table, no, I didn't do the F. Apparently, I didn't do the F table. Yeah. Z. Okay, I thought I did all the tables. I didn't do them. If I did do the table, we could we could look at here, but I didn't do that one. So I'll stop the share and realize that you have to look on page 499 and always the first column and the 8th row for the first and 8th degrees of freedom, and you'll see the 532 there, which the slides got. So we can stop this share, and then I can share the PowerPoint again. I thought I did that table. Now calculating the test. Right. So they computed the R squared, SSE, and so forth. Added one column to get the results from their table calculation. So they went through the table calculation, and finally they came up with these values, which 6.98 is in the rejection zone. And did we get 6.98? And these two numbers here in our ANOVA table, yeah, we can look for those and see if Excel got it right. And we then can share Excel result. The numbers should look familiar, and they do. And the significance level being below the 0.05, which is used in the table there, page 499. I think they only give you, yeah, alpha is equal to 0.05. It tells you at the bottom. So with the textbook, you can only do these F tests with alpha is equal to 0.05. There may be circumstances where you wouldn't do that. However, so being this is less than 0.05, it's all equivalent to saying we reject the null and we assume there is a significant slope. Okay, rejection zone, we reject. Strong evidence to support the claim. Something, okay. All right. Just a lot to be seeing with regression. A lot of numbers bouncing around. The first time I read through this kind of stuff, I not in this book, but when I was young, I'm thinking it was 1983, I think. Yeah, or it was 83 or 84. I'm having a hard time remembering. I think it was 83. Another way to look at this is the standard error of estimate. So the square root of MSE from our table is a concern, useful result. Is the standard error of estimate. And there's relationships here between correlation coefficient and sums of squares and so forth, and those are mentioned here. So can you cheat doing these calculations various ways? Yes, you can. However, it's probably for much of the regression calculations, you'd want a computer program to give you the results, and many computer programs will give you ANOVA tables for regression, and some of them are free. R, for example, is free and will do all these things. So it's important to just think about the assumptions for the simple regression. It's a linear relationship. It's a straight line. It is fitting the line we would draw with a ruler. Homoscedasticity. Okay, the variation is the same about the line as x goes. So we have the variance doesn't change, or the standard deviation of the parts that we of the points that we assume occur randomly around the line. The mean or the expected value of the error term is 0. Okay. And the error terms are independent of each other, so they're not correlated. So if we do get the error terms and we treat the error terms and plot them, and they don't look independent, they and they don't look uncorrelated, we've probably should use a more complex equation to do the fit, and we just aren't showing that in this one chapter discussion of regression. Okay, so what have we done today? We did the attendance, and I guess I left a tech check in there. I haven't done a tech check for a couple weeks. These slides were something I originally prepared last semester, and I was doing tech checks most of the semester because we were five we were five we were 5 weeks in when we switched to the distance and didn't have the tech support. We talked about what the y-intercept and slope were. Slope is rise over run, the change, and y-intercept is again where the fitted line crosses the y-axis, and they're the letters. We designated those as draw the slope. Slope is B, and it's rise over run. And the intercept is A. We have example 12.1. We introduced, and that was the one with hours of exercise and calories. We've talked through simple regression terms, and we then used went through an ANOVA summary table and showed you that Excel will give you that. There is a hypothesis testing for simple regression, and there's a standard error of estimate shows up, and there are some mathematical relationships between R and the slope. So those are mostly a curiosity, but you can look them up and answer some questions. And what's really important is this simple linear regression. It doesn't work if things are more variable on uh, if you've got more variability with x's. It does fit just straight lines perfectly. And I guess we just talked about that. And the average of the errors is supposed to be 0, and the errors should also be uncorrelated. So that's what I've got ready for this week. There is an assignment. There'll only be one more week of new material set up, and we'll close out the class pretty soon. The second exam is has been up, and I hope some of you have submitted things. Things are starting to, I believe things are starting to settle out with me being able to work on various problems. So and get your grades together. Hopefully, I'll be able to get a better handle on that. Personally, I had a lot of stuff to go through, and then the country certainly had a lot to go through with the. I guess I can stop the share. Country had a lot to go through with the election. Little different than 4 years ago. 4 years ago, early on Wednesday morning, we knew the results, and that's actually the more common thing. But now we waited till Saturday and late in the morning. I believe the answer was. My son called me and said, "Hey, it's been called for Biden." Most of the networks had done it, and I'm guessing it was around 10 in the morning. So we had that. So I guess any questions about the course overall, or from anybody? Oh, Megan's here. I didn't see you. I can go back and mark you. Let's I can share the screen and share. I didn't mark you as attending yet, Megan. So
Oh, sure, hold on.
okay. Oh, All right. There we go. I can stop the share. Okay. Yeah, I didn't notice when you arrived, Megan, until later. So yeah. We're switching to the YouTube videos, and we'll have those recorded. So that's new, and we're cleaning up the class, and I do have most of the first exam grades up on Genzabar and your marked up files for that. So I'll get to marking things up and setting things up. Likely things have settled out a little bit for me personally the last few days. Yeah, I guess that's the simplest way to say it. Okay. So thanks everybody for listening, and if you showed up late, we'll see the we'll see the end, and I can stop the recording now and maybe wait to see if anybody wants to hang